Shane takes out a car loan of €15,000 at an effective annual interest rate of 9.5%. The loan is to be repaid by equal monthly payments, starting 1 month after he draws down the loan, and is to continue for 3 years, i.e. 36 repayments, because 12 times 3 is 36 months, so 36 repayments. Question 1. Find the monthly interest rate correct to 6 decimal places that is equivalent to an annual interest rate of 9.5%. So we let I be the monthly interest rate equivalent to an annual rate of 9.5%. So we're going to use our compound interest formula, which is F equals P times 1 plus I to the power t. So P being the principal amount, I being the interest, and t being the time. So annually, so yearly, we have F equals P bracket 1 plus 0.095 bracket to the power of 1. So the 0.095 is the 9.5%, and it's to the power of 1 because it's 1 year. And then we use the same compound interest formula, but this time we work out monthly. So it's F equals P bracket 1 plus I bracket to the power of 12, because there's 12 months in 1 year. So annual is to the power of 1 for 1 year. Monthly is to the power of 12 for 12 months. So we're trying to figure out what this I is. We're trying to figure out what interest rate will equal 9.5% annually. So what we do is we let them equal to each other, because they're both equal to F. So obviously we don't bring down the F's, we just bring down everything on the right of the equal sign. So we have P bracket 1 plus 0.095 bracket equals P bracket 1 plus I bracket to the power of 12. So this is to the power of 1, I just didn't bother writing it down here because it's the same thing. We can cancel the P's on either side, and then 1 plus 0.095 is 1.095. We cancel the P, so we bring down 1 plus I to the power of 12. So we want to solve for I, we want to get the I in its own. So the power of 12 comes over the equal sign and becomes the 12th root. And the 12th root of 1.095 can be rewritten as 1.095 to the power of a 12th. And we've just swapped these around. So on the left now we have 1 plus I. So 1.095 to the power of a 12th, which is the same thing as the 12th root of 1.095, will give you 1.0075915534. And then subtracting that 1 to solve for I, to get the I on its own, you end up with I equal to 0.0075915534. Now the question asked for 6 decimal places, so the final answer would be I is equal to 0.007592. And that's correct to 2 decimal places. However, we will use the longer answer, so more decimal places, in part 2 when we're using I, because that will give us a more accurate answer for part 2. Part 2. By using the equation of value, when he draws down the loan, find the amount of his monthly repayments. So we let €1 be the equal monthly repayments, then the value of all the repayments on the date he draws down the loan is A over 1 plus I, plus A over 1 plus I squared, plus A over 1 plus I cubed, plus dot 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 A over 1 plus I to the power of 36. So we imagine we would continue writing this out all the way up as far as the power of 36. In part 1 we worked out that I is equal to 0.007591534, and we're going to let V equal 1 over 1 plus I, so we sub in this in place of I, so 1 over 1 plus 0.007591534, and that will give 0.9924656629. Then value of repayments is going to be A multiplied by V plus V squared plus V cubed plus ... up as far as V to the power of 36. So what's happened here is we took this equation, or formula, and we factorized out the A. The A was common in all parts, so we took the A outside. And we noticed that if we do take the A outside, what's left on the inside is 1 over 1 plus I, plus 1 over 1 plus I squared, and so on. So what's left on the inside is 1 over 1 plus I to a power that's been raised each time. So really what's left on the inside is V. So this formula, we factorized out the A, and we rewrote the common ratio, which is 1 over 1 plus I, which keeps getting raised to a higher power. We replace that with V. So we have A times V plus V squared plus V cubed plus ... up as far as plus V to the power of 36. So now using this formula, this rewritten formula, we're going to use our SN series formula, which we can find in our sequences and series section in our formula book, which is A times 1 minus or to the power of n all over 1 minus or. So in this case, the A is going to be V. The or will also be V. And the n will be to the power of 36. So that's because the A stands for the first term, which is V. And the ratio, what's multiplied on each time, is also V. And obviously the power of 36 comes from here, which ultimately came from the 36 repayments. So putting into your calculator 0.9924656629 in place of the V, multiplied by 1 minus 0.9924656629 to the power of 36, divided by 1 minus 0.9924656629 will give us 31.39630798A. Remember, the A is still stuck on. So we let this equal to 15,000 because that's the amount of the loan. And then we solve for A. So 15,000 divided by 31.39630798 gives us 477.76. So the monthly repayments are €477.76.